Let's talk about hypothesis testing with inferential approaches. This slideshow is copywritten by the Probe Consulting Company and Dr. C. Harold McManus, all rights reserved, 2010. Key points. We'll talk about two types of testing, possible outcomes, type 1, type 2 errors, and what an alpha is, and also one-tail and two-tail steps. What are the key points? You ask yourself, what is the probability of an outcome when you are doing an assessment or testing your data? Are your findings due to chance factors or something that you're doing in your experiment, which are experimental factors? Ask yourself, what if the treatment really made no difference at all? Would you still find the same outcome? Did your treatment work? And those are the key points to consider. If the probability of error is low, we reject chance factors and assume that something is going on. We, in essence, reject our null hypothesis. Look at the observation. In this cycle, the observation, what you see, you have a working hypothesis. You say, I think something is going on. That's your working concept, if you will. Then you make it more formal. There will be a significant difference, correlation, but you make it more formal. Next, you do the experiment. You test your hypothesis, and then you find support or you don't find support. If you do find support, you reject the null. If not, you fail to reject the null. Speaking of the null, let's talk about two hypotheses. Whenever you do a study, you always test the null. And even though this may be counterintuitive, whenever you test the null, you say you don't believe that anything is going on. There will be no significant correlation, no significant difference. The null says nothing is going on. And the null is HO. H and the O that you see right there. Your research hypothesis says that something is going on. There will be a difference. There will be a correlation. HO says no effect. H1 says some effect. Something is going on. And we test the null because it offers more precision. That's why we test the null. Here's your example of what a null looks like. There will be no significant difference in second year GPA based on high school preparation. Keyword no, nothing's going on. But you must also put your H1. There will be, and really you believe H1. You think something is going on, which is why you're doing the study, but you can only test the null. You can only test the null. Here are your steps. I'm going to make the assumption that a private school education is different from a public school education. So here is my two groups, private school, public school. And I'm testing grade point average at the sophomore level. An independent t-test. There's my mean 1, there's my mean 2. My independent variable is school. My DV, or dependent variable, is grade point average. I do my analysis, and I make my conclusion. I reject the null or fail to reject the null. And those are your only two possible outcomes. You reject the null or you fail to reject the null. There are no other possible outcomes. I gave you a sample of what T may look like right here. Okay. If you reject the null, then you are saying that something is going on. Because if the null says that nothing is going on and you reject it, if you reject nothing, ain't but one thing left, something. Okay? All right. So if you reject the null, that is saying that you do believe that something is going on. And if you reject the null and you are wrong, that's called a type 1 error. Now, alpha is a key point in rejecting or not rejecting the null. As you see here, we have alphas of 0.10, 0.05, 0.01, and 0.001. And alpha is your probability of making a type 1 error, or saying that something is going on when truly nothing is going on. 0.10 is 1 chance in 10 of being wrong. 0.05 is if you say, I reject the null, 5 times you were incorrect, 95 times you were correct. 0.01, 1 time you may be wrong, but 99 times you were correct in rejecting the null. And 0.001 is 1 chance in 1,000. This is what we call your zone of rejection. And here you see 0.10, 09, 08, 07, 06, and 0.05 is right here. In most research studies, we choose 0.05. 0.01 if you want to be more sure, and 0.001 if you want to be really, really sure. Type 1 error. I reject the null, but I was not supposed to do so, which means I say I found something, but truly I did not. Type 2, I failed to reject the null, but I should have. I say nothing is going on, but something truly is going on. That's type 2. If I do a one-tailed test, I am predicting a direction. I think something will get bigger or smaller, more or less. Two-tailed means I don't know the direction, but I know something is going on. That's what two-tailed implies. Here are your 5 steps for conducting your hypothesis test. Please look those over. Here are the steps to formally test your hypothesis. Look that over. And here is what you would look for in your N as you look at the population. You have to make sure it has a normal distribution. Nothing is skewed. You have to look at the distribution first before you conduct your hypothesis test. And we'll stop here with our introduction to hypothesis testing. Okay? Thank you very much.